Step into a dimly lit 19th century laboratory where the air is thick with the scent of old parchment and chemical reagents. Dmitri Mendeleev sits hunched over his wooden desk, surrounded by a chaotic mountain of scattered notes and complex data. The flickering candlelight casts long shadows across his face as he meticulously organizes his thoughts on the known elements. He was driven by a singular, burning obsession to find a hidden, logical order within the vast, messy world of chemistry. At the time, scientists knew of many elements, but they were treated as a disconnected list of isolated facts. Mendeleev believed there was a deeper pattern waiting to be uncovered, a rhythm that governed how matter behaves. He began to arrange these elements based on their atomic mass, looking for recurring properties that might repeat over time. This pursuit led him to propose the periodic law, a revolutionary concept that changed the trajectory of scientific thought. The law states that when elements are ordered by their atomic mass, their chemical properties show a clear, repeating cycle. Watch as early, hand-drawn layouts of the periodic table begin to form on the screen, piece by piece. Mendeleev carefully placed each symbol, observing how certain characteristics seemed to echo across different rows and columns. It was a puzzle of massive proportions, requiring him to balance known data with his own intuition about chemical relationships. Crucially, Mendeleev did not merely list the elements he knew. He took a leap of faith that defied conventional wisdom. He deliberately left empty gaps in his table, asserting that these spaces belonged to elements that had not yet been found. These were not errors in his work, but bold, calculated predictions based on the mathematical logic he had observed. He treated these missing pieces as real entities, waiting in the shadows of the natural world to be discovered. On his charts, he carefully labeled these empty spaces with specific details about their expected atomic weight. He even predicted their chemical behavior, describing how they would react when combined with other known substances. This was a daring move, as many of his contemporaries doubted that such unknown elements could even exist. Consider his famous prediction of a substance he called Eka aluminum, a theoretical element that remained hidden from view. Years later, chemists identified the metal gallium, and its properties matched Mendeleev's calculations with startling accuracy. He also foresaw the existence of Eka silicon, which we now recognize today as the vital element germanium. His predictions for germanium were so precise that they left the scientific community in absolute awe of his foresight. He even predicted the existence of scandium, which he referred to as Eka boron, further validating his revolutionary framework. Each discovery was a triumph, proving that his table was not just a list, but a roadmap to the unknown. Infographics now appear on screen, showing side-by-side comparisons of his early predictions versus the actual properties discovered. The data points align perfectly, demonstrating the incredible precision of his original, handwritten calculations. These comparisons highlight why his work was so groundbreaking for the field of chemistry in the late 1800s. His ability to predict the physical nature of undiscovered matter transformed chemistry into a truly predictive science. It moved the discipline away from simple observation and into the realm of rigorous mathematical forecasting. This success provided the ultimate validation for the periodic law, proving nature followed a deeply structured, repeating pattern. The scientific world finally accepted that elements were not random, but part of a grand, interconnected design. Transitioning to the modern periodic table, we see these same foundational trends organized into clear groups and periods. The layout we use today is a direct descendant of the logic Mendeleev pioneered in his quiet laboratory. Modern visuals highlight the periodic trends, showing how atomic structure dictates the behavior of every element. We see the transition metals, the noble gases, and the reactive halogens all falling into their rightful places. The periodic table has since become the absolute bedrock of modern chemistry, guiding research and industrial innovation. It is the essential tool for engineering, helping us understand the properties of materials at a molecular level. From the development of high-performance alloys to the creation of new polymers, the table is our constant guide. Modern laboratory footage shows researchers using the table to synthesize new compounds with specific, desired traits. The silicon in our computers and smartphones owes its utility to the patterns first mapped out by Mendeleev. The metals in our infrastructure and the catalysts in our green energy technologies are all understood through this lens. Every element symbol on the chart represents a piece of the puzzle that Mendeleev helped us assemble. Atomic models spin on screen, illustrating the electron configurations that explain why these periodic trends exist. It is a beautiful synthesis of physics and chemistry, showing the elegance of the universe at the smallest scale. Mendeleev's legacy lives on every time a student or scientist uses these patterns to study atomic behavior. His work reminds us that even the most complex systems often have a simple, underlying order waiting to be found. The periodic table remains a testament to human curiosity and the power of logic to unveil hidden secrets. It is a bridge between the known and the unknown, constantly inviting us to explore further into the microscopic. As we look at the table today, we are looking at the culmination of centuries of human inquiry. It stands as one of the greatest achievements in the history of science, a masterpiece of classification. Thank you for joining us on this journey through the history of chemistry and the genius of Dmitri Mendeleev. We have explored how one man's vision turned a collection of elements into a predictive, scientific tool. His story is a powerful reminder of how persistence and observation can lead to monumental scientific breakthroughs. We hope this look at the periodic law has deepened your appreciation for the building blocks of our world. There is always more to discover, and the periodic table remains our most reliable guide in that search. If you enjoyed this exploration of science, please consider subscribing to our channel for more chemistry videos. We are dedicated to bringing the history and beauty of science to life through engaging visual storytelling. Don't forget to like this video if you found the story of Mendeleev and his table inspiring today. Share this content with fellow science enthusiasts and join us next time as we uncover more mysteries of nature.